Welcome everybody to my second Hotwash video. Today I'm going to be talking about glutamate receptors. So just for some basic information to get started on the function of cell signaling. So receptors, typically they're transmembrane proteins, meaning that they're a protein that goes all the way through the cell membrane and they receive signals, and these signals that they receive are typically ligands, which are molecules that will just bind a specific receptor. And then upon ligand binding, a signal will be activated and sent through the cell. So specifically here, we're going to be talking about the glutamate receptor, and a lot of these are G-coupled protein receptors. There's a different one that we'll talk about, but we're mostly going to talk about the G-coupled protein receptors. So upon ligand binding, this is going to make a change in that transmembrane protein of the receptor that is going to create a pocket for the G protein to come and bind. And upon the G protein binding, this is going to cause GDP to fall off the trimeric protein, meaning that this protein is made of 3 subunits. And upon GDP falling off, GTP will come and bind to the alpha subunit of the G protein, which then activates it, and then the alpha subunit will go and activate other enzymes. So for a good visual here, we can see the trimeric protein is just shown as one protein here, but the G protein is going to come and bind to the receptor. GDP is going to fall off. GDP is going to come on and activate the alpha subunit, which is then going to go and activate other proteins to kick off the response. So the glutamate receptor structure, specifically, it's a dimer of 7 domain transmembrane proteins. Here we see the transmembrane protein spanning the membrane, and then it has also a dimer of the extracellular receptors, and it looks like the Venus flytrap. If any of you played Super Mario, you probably recognize this guy. He breathes fire. He probably has killed you a few times, but this is what that extracellular portion really looks like. And because it has 2 extracellular binding sites, 1, 2, or 0 ligands can bind. I tried really hard to find some academic articles talking about the responses that this receptor gives upon just 1 ligand binding. I couldn't find anything specifically, but from what I was reading, we can just know that there's going to be a varied response based on the amount of ligands that bind to the extracellular domains. So as I talked about earlier, there are examples of glutamate receptors that open ion channels. I think these are actually more common. These are usually found in neurons. They're referred to as ionotropic receptors. And upon glutamate binding, which might go without saying, this is the specific ligand that the glutamate receptor binds to, you're going to have different neurotransmitters be able to, different ions that are able to leave the neurons or enter the neurons, which are going to elicit very fast neurological responses. So the glutamate receptors, though, that we're talking about specifically here are G proteins. These are referred to as mebatotropic receptors. Group 1, again, we're going to go into more detail on these on the next few slides, but group 1, mebatotropic receptors, these are going to activate phospholipase C, which is in turn going to increase intracellular calcium levels. Group 2 and group 3, they do pretty much the same thing. They inhibit adenylate cyclase, which is going to decrease CAMP levels, which is a secondary messenger, which we're going to talk about in the next few slides. But group 3 is just a little different because it can have varying effects based on the cell type, where group 2 is pretty uniform across all cell types. So here, group 1, mebatotropic glutamate receptors, what they're going to do is the ligand's going to come and bind to the glutamate receptor. Glutamate's going to bind. And then the alpha subunit, as we talked about, is going to be activated, which is then going to go and activate PLC. PLC is then going to cleave its substrate to produce water-soluble IP3. And IP3, this molecule is going to travel through the cytosol into the endoplasmic reticulum, bind to receptors in the endoplasmic reticulum, which are going to open calcium channels, which is going to raise the calcium levels in the cytosol, which is going to induce a lot of different metabolic pathways and effects and activate different proteins that we're not going to talk about for the sake of time. Group 2 and Group 3 mebatotropic glutamate receptors are essentially going to, as we talked about, activate upon glutamate binding. The alpha subunit will be activated. But in this case, the alpha subunit is not going to activate adenyl cyclase, it's going to inhibit it, which is going to shut down CAMP being produced. And I talked about earlier, we're going to talk about what CAMP is as a secondary messenger. A secondary messenger is essentially a molecule that is going to act as a messenger in the cytosol to go and activate different proteins, which will then kick off different cellular processes. So with CAMP levels being down, these downstream processes cannot happen. So there's going to be a lot of proteins that aren't synthesized, a lot of proteins that aren't phosphorylated or being activated that are not going to have downstream effects in the cell. And again, we could talk more about this, but for sake of time, we're just going to focus on really what the specific responses of the glutamate receptor in with adenyl cyclase. Well, that's the video. I hope you learned something. I hope this was a benefit to you. And yeah, I'll see you in class sometime soon. But thanks for watching, and I hope you guys have a good day.